Hello, 7.2 is going to take a look at properties of exponential functions. So these are transformations that come up with exponential growth and decay problems. So please write down this equation. You'll notice the a, the h, and the k are still the same from the previous chapters. So the a is in charge of stretching, compressing, or reflecting across the x-axis. The h is in charge of moving it left and right, and the k is in charge of moving it up and down. So that part's the exact same as before. So you'll notice if the a is greater than 1, it's stretching it. If the a is between 0 and 1, it's compressing it. And if the a is negative, I have an error here, that it's reflecting it across the x-axis. The h here is moving it left and right. It's the opposite of what you would think. So if it is positive number, then it's moving it to left. If it's a negative number, it's moving it to the right. The k is in charge of moving it up and down. If it's positive, it's going up. And if it is a negative number, it's moving down. So for our first example, notice it's in that format. So we have y equals negative 1/3 times 3 to the x power. So this negative 1/3, notice how it's negative in our 1/3 in the a slot. So that's going to be two transformations. The negative itself means it is reflecting across the x-axis. The 1/3 means it is compressed by a factor of 1/3. Okay, and then this y equals 3 to the x power, that's just our parent function, so that's what we're going to compare it to. So we don't need to worry about that 3. It's not in charge of any transformations. So it is just reflected across the x-axis and compressed by a factor of 1/3. For this next one, we have y equals 2 to the x minus 4 power. Our parent function that we're comparing it to would be y equals 2 to the x power. And since inside parentheses it's x minus 4, it's going the opposite direction of what we think. So it's going to the right 4 units. This next one, we have y equals 20 times a half to the x power plus 10. Our parent function would be y equals a half to the x power. It's going to be stretched by a factor of 20 because that is in our A slot. And then it's moving it up 10 units because that is in the K slot. Now these next ones, I want you to see where the E button is on our graphing calculators. So notice in this first column, it's right above the LN button. So to get it, we need to do second and then the LN button. And that's going to give us E to whatever power. So for these two problems, we just want to make sure that we know how to put them into the calculator to get us started for the next examples. So we have e to the third power, which is 20.08553692. Just round to 3 decimals, so 20.086. The next one, we have e to the 8th power. So we're going to do second and then that's LN button to bring up our e, and then we have to the 8th power. So we have 2,980.95, and then we're going to round that to 8. Alrighty, now where this is going to come into play is compounded interest. So if we look at our compounded interest equation, we are going to have the equation y equals p times e to the RT power. This p stands for our principal. The e is going to be the e button on our calculator. The r stands for rate. It's going to be a percentage. We need to change it to a decimal. And then our t is time. And that should be in terms of years. And the RT is all in the exponent spot. So for this first one, we have $3,000. Our annual interest rate is 5%. It compounds continuously. And how much do we have in our account after 4 years? So this one is different from the first section in this chapter because it wasn't compounded interest. This one's compounded. So this is the equation we need to use for compounded interest. Okay, so our $3,000, that's our initial amount, so we're going to plug that in for our P. Our E, we just keep the E and push that E button on our calculator. Our 5%, we're going to change that to a decimal by moving the decimal back 2 places. so 0.05, and after 4 years, so we plug in 4 in for our rate. Notice the 0.05 times 4 is all in the exponent spot. So from here, I would take 0.05 times 4 and just multiply those, get 0.2. So then we're going to plug that into our calculator, 3,000 times our E button to the 0.2 power, and get its money, so we need to round to 2 decimal places, $3,664.21. Now this next one we have, let me straighten it out a little bit, it's crooked, I apologize. So for this one, notice we have $1,250, our 2.5% annual interest compounded continuously. It's compounded, so we know we need to use this equation. How much money will we have in our account after 3 years? So our principal is going to be $1,250. That's our initial amount that we're putting into our account. And then our E, we're going to put the E button on our calculator. This percentage, we need to make a decimal by moving it back 2 places. So we have 0.025, and then after 3 years, so times 3. Now for this one, if you don't want to go ahead and multiply those and you just want to put it in your calculator for one step, how you're going to type it into your calculator, you're going to put your 1250 times our E, and then you're going to put 0.025 times 3 all in parentheses so that the calculator knows that's all in the exponent spot. So then we get $1,347.36. Now, one last thing, I want to make sure that we know the difference between simple interest and compounded interest. The word problem is going to tell you that it's compounded interest, so you'll know to use this problem, or the last one from the first section was simple interest, so it will not say compounded, so we know to use that one. But what compounded interest simply means is that if it's compounded annually, that let's say we start off with that $1,250, we get an interest of 2.5%, so that builds after that first year. Well, then that new amount that we have in our account, then it's 2.5% of it, and then we get that for the next year. Well, then it's our new amount at the end of the year, we take 2.5% of it, and it keeps compounded. So if we have the choice to work with a bank and have simple interest or compounded interest, we want compounded interest so that it's going to build a lot quicker.